Hello, this is Sunny, and this project was completed by Shogudar Hassani and Arup Datto. In this video, we demonstrate our project titled Secure RESTful Communication between Client and Server. So, the goal of this project is to start with a basic REST API and gradually improve its security by applying different cryptographic techniques through several stays. We enhance the system, provide confidentiality, integrity, replay protection, and also secure key exchange and certificate-based authentication. Now, I will briefly explain the structure of our project and role of each file. So first, I'll explain this server-side file. For this, we have server.py, the main server, and also we have server fake py fake server for replay related test. Also, we have server superfig Python file, this replay server that use a saved valid response. Also, we have server server updated file. This one, this contains updated server with replay protection. For the client side, we have client client python file. This one, this actually the main client code actually. So also we have client updated file, this updated client with replay protection and certificate verification. And also we have keys, this key generate python file, generate server RSA key pair for the server. And also we have key generate CA Python file, generate CA RSA key pair. And also we have cert key Python file, this one, create certificate for the server public key. And also we have this one, this one, also we have this one, public key, and also secret key, that is server RSA keys. Also we have this one, public CA key and secret CA key, CA RSA key actually. And also we have this one, pk.crt file, signed certificate for the server public key. And for this finally this explain the environment setup, dependencies, and the step-by-step instruction for running systems. This project is divided into four main tasks, where each task adds a new security feature to the system. So in task one, text on this one is a basic REST server and client. We implement a basic REST server and client. The server actually provides an endpoint called weather, which return the static, static JSON object containing weather information such as location, temperature, condition, and humidity. The client sends a request to the server and prints the response. So at this stage, there is no security protection. No security protection, meaning that the data is transmitted in plain text using this wordcheck. We can observe that weather information is fully visible in the network traffic. So this demonstrated need for secure communication actually. So in task 2, uh, for this text 2, I will open this text 2 again. This text 2, we improve the system by adding symmetric cryptography. First, we introduce a pre-shared secret key between the client and server. We then used AES encryption in CTR mode to ensure confidentiality, which prevents attacker from reading the transmitted data. Reading the transmitted data. So um, next, we implement this one the when this one when we then use this AES encryption in CTR mode to ensure confidentiality, which prevents attackers from reading the transmitted data. Next, we implement this HMAC, which provide message integrity and authentication. This allows the client to verify that message has not been altered. So, and also later we upgraded the system. Yes, GCM authenticated encryption, which combines the confidentiality, integrity in a single cryptographic operation. During this phase, we also demonstrated the replay attack. And also, since the project code has now been updated to the final secure implementation, the earlier version of this Tux 1 and Tux 2 were replaced. So the live demonstration is not available in the current setup. However, this screenshot, this Tux 1 and Tux 2 screenshot explanation and result for this Tux are fully documented in our project report. So now we will demonstrate task 3 and task 4, and which represent the final secure design of the systems. Now I will demonstrate the final secure implementation. So I'll go my BM and I'll go to my BM, and then first to generate the server RSA keys. For this I will run on the following command, cd and then I'll check the files. Yeah, I got this file, and now I'll run this keygen file. So this creates a public.key and secret.key. So next we generate the certificate authority keys. For this certificate authorities keys, I'll I'll check again, and I will go to cd gen.ca folder. I'll check here and I'll run this gen file. This creates a public CA key and a secret CA key. So RSA key pair generated successfully. So next we generate the server certificate. For the server certificate, I'll go to the server updated file, and I'll go to this server updated file, and I'll run this cert. This creates certificate file pkcrt. So public certificate created successfully. So now we can start the secure server. For the secure server, um, so now we can run this one server update, sorry, server update.py. So the server is now running on this 127's IP. I will open another terminal, and I check it here, less folder, and I will go to client updated folder. I check this file, this client. I'll run this file now. Run this file. Yeah. Actually, this client first verified the server certificate using the trusted CA public key. After successful verification, the client generated a session key, encrypt it using a server RSA public key. The server decrypt the session key using its public private key, and both sides communicate using AES GCM authenticated encryption. So finally, this client successfully decrypts the weather data returned by the server. Actually, this project demonstrated how a simple REST API can be upgraded step by step into a secure communication system. So this final implementation provide confidentiality, integrity, replay protection, secure session, key exchange, and certificate-based server authentication. This project actually helped us apply theoretical cryptography concept in practical client server environment. Thank you all.